Hello viewers, in today's session we are going to discuss another important problem from integrals, and in this class we are going to evaluate this integral that is from 0 to 1, and we have x raised to 5 divided by the cube root of 1 minus x cube, right? So we'll evaluate this integral with the help of the concept of beta and gamma functions, right? And before applying the concept of beta and gamma functions, will make use of the method of substitution, right? So let us start. So here we'll try to convert this integral into a beta function, which is defined by beta m comma n is equal to 0 to 1, and we have t raised to m minus 1, 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So the purpose of applying the method of substitution is to convert or to reduce this integral into this form, right? So here let us first take this integral as I, and let us make this substitution, that is t is equal to x cube, so that we have x is equal to t raised to 1 over 3. Now let us differentiate x with respect to t to get the value of dx. So we have dx over dt, that is equal to d by dt of t raised to 1 over 3, and using the power rule here, that is d by dt of t raised to n is given by nt n minus 1. So we have 1 over 3 t raised to 1 over 3 minus 1. So we have 1 over 3 t raised to 1 minus 3 over 3, that is 1 over 3 t raised to minus 2 by 3. So we can now write dx is equal to 1 over 3 t raised to minus 2 by 3 dt. Now here the limits of integration vary from 0 to 1. So when x is equal to 0, which is the lower limit, the value of t can be obtained from this relation. So we have t is equal to 0 cube, that is 0. And when x is equal to 1, which is the upper limit, so we have t is equal to 1 cube, that is equal to 1, right? So now we can write this integral I in terms of t as 0 to 1. The limits remains the same, and x raised to 5. So x is t raised to 1 over 3. So we can now write 1 over 3 raised to 5, and then we have cube root of 1 minus t, and for dx we can now write 1 over 3 t raised to minus 2 by 3 and dt. So now let us simplify or rearrange this integrand, and we can take 1 over 3 outside the integral. We have 0 to 1 t raised to 5 over 3, and then we have here t raised to minus 2 by 3. So we can use the laws of exponents to add these two numbers. So we have plus minus 2 by 3, and in the denominator we can now write 1 minus t raised to that is 1 over 3, because this is cube root of 1 minus t, and here we have dt. So now I is equal to 1 over 3, 0 to 1, and t raised to this is 5 minus 2, 3, and 3 over 3 is 1. So here we have 1, and then we have 1 minus t raised to 1 over 3 dt. Now we can write 1 over 3, 0 to 1, t raised to 1, and we can take 1 minus t raised to 1 by 3 to the numerator. We have 1 minus t raised to minus 1 by 3, and here we have dt. So now we can write 1 over 3 Here we have 0 to 1, and t raised to 1 can be written as m minus 1. So we can write simply 2 minus 1, because 2 minus 1 is 1. And here we have minus 1 over 3, and minus 1 over 3 can be written as 2 by 3 minus 1. So now this integral is of this form, and here the exponents, that is 1 is equal to 2 minus 1, and minus 1 over 3 is 2 by 3 minus 1, because 2 by 3 minus 1 is 2 minus 3 over 3, that is minus 1 over 3, right? So now if we compare this integral with this one, then the value of m is 2, this is 2, and the value of n is 2 by 3, and obviously 2 and 2 by 3 are greater than 0. So we can now write I is equal to 1 over 3 beta function, that is beta of m comma n. M is 2 and n is 2 by 3. So now to get the value of beta 2 comma 2 by 3, we'll make use of this important result which connects the beta function with gamma function. So beta m comma n is given by gamma n divided by gamma m plus n. Now we can write here 1 over 3, and using this result we have gamma 2, then gamma 2 over 3 divided by gamma 2 plus 2 by 3. So the value of the integral I can now be written as 1 over 3. Now gamma 2 is given by simply 1, because we know that gamma n plus 1 is equal to n factorial, where n is a positive integer, right? So gamma 2 can be written as 1 plus 1, that is equal to 1 factorial, that is simply 1. So gamma 2 is equal to 1, and we'll keep this term as such, that is gamma 2 by 3, and in the denominator we have gamma 8 over 3, right? Now let us find out the value of gamma 8 over 3 using this result, that is gamma n plus 1 is equal to n times gamma n, right? So this is another important result. Gamma n plus 1 is equal to n times gamma n, where n is some fraction here. So we can now write uh, here we have a positive fraction, that is 8 over 3. So 8 over 3 can be written as 5 over 3 plus 1, that is of the form gamma n plus 1. So here n is a positive fraction, that is 5 over 3. So we can apply this rule. So we have 5 over 3 gamma 5 over 3. Now further 5 over 3 can be written as 2 over 3 plus 1. Now again this term is similar to this one, n plus 1, and again n is a positive fraction, that is 2 by 3. So we have 5 over 3, and applying this rule we have 2 over 3 gamma 2 over 3, right? So this is 5 times 2 is 10, 3 times 3 is 9, and gamma 2 over 3. So now substituting this value of gamma 8 over 3 as 10 over 3 times gamma 2 over 3 in this expression, I is now equal to 1 over 3. This is 1, and we have simply gamma 2 over 3, and this is 10 over 9 gamma 2 over 3. Now these two terms get cancelled, and we are left with 1 over 3 times here we have in the denominator 10 over 3. So taking 9 to the numerator, we have 9 over 10. So this is 3 times 3 9, that is 3 over 10. So viewers, the value of this integral I is equal to 3 over 10, which can also be written as 0 0.3. So the value of this integral is 0 0.3 or 3 over 10. Hello viewers, in today's session we are going to discuss another important problem from integrals, and in this session we are going to evaluate this integral, that is integral from -1 to 1, and the integrand is square root of 1 plus x divided by 1 minus x, and here we have dx, right? So here in this class we'll see how we can easily evaluate this definite integral using the concept of beta and gamma functions, right? So let us start. So let us call this integral as I, right? Now see, this integral can also be evaluated with the help of trigonometric substitution, but here we'll prefer the method of beta and gamma functions. So here by making a very useful substitution, we'll try to convert this integral into this form, that is 0 to 1, and we have say t raised to m minus 1 and 1 minus t raised to n minus 1 dt. So we'll make a substitution here, and will then convert this integral into this form, and this integral is known as a beta function, that is beta m comma n, right? So let us substitute here. X is equal to 2t minus 1. So this is the important substitution which we are going to use to convert this integral into beta function. So now when we take x is equal to 2t minus 1, then this integrand, that is square root of 1 plus x over 1 minus x, it reduces in terms of t like this, that is 1 plus x. For x we can write 2t minus 1, and here we have 1 minus x, so we can now write 1 minus 2t minus 1. So we can solve it. This one and this one get cancelled, and we are left with 2t, and here we have 1 minus 2t plus 2, and this is further equal to 2t divided by here we have 1, right? So this is 1 plus 1 is 2, and this is minus 2t. So let us take 2 common in the denominator. So we have 1 minus t. Now this 2 and this 2 get cancelled. So we have now square root of t over 1 minus t, right? And we can also write this expression as square root of t divided by square root of 1 minus t, and square root of t can be written as t raised to half, and here we have 1 minus t raised to half, and taking 1 minus t raised to half to the numerator, we have t raised to half, and then we have 1 minus t raised to a minus half, right? So when we take this substitution, x is equal to 2t minus 1, then square root of 1 plus x divided by 1 minus x is now equal to this expression. So now let us differentiate x with respect to t. So we can now write dx over dt is equal to the derivative, that is d by dt of 2t minus 1. So here the derivative of t is 1 and derivative of 1 is 0. So we have 2 times 1 minus 0, that is equal to 2. right? So we can now write dx is equal to 2 dt, right? Okay, now let us change the limit. So here the lower limit is x is equal to -1, and the upper limit is x is equal to +1. So when x is -1, then t can be calculated from this equation. So we have -1 is equal to 2t minus 1. So 2t is equal to -1 plus 1, that is 0. So t is 0 over 2, that is 0, right? And when x is +1, then the value of t can again be calculated from this expression. So we have +1 and 2t minus 1, and taking -1 to this side, we have 1 plus 1 is equal to 2t. This is 2 is equal to 2t, and t is equal to 2 over 2, that is 1. So when x changes from -1 to +1, then t varies from 0 to 1. So now let us write this integral in terms of t. So we can now write I is equal to integral from 0 to 1, because when x is -1, t is 0, and when x is 1, t is 1, right? And for square root of 1 plus x over 1 minus x, we can now write t raised to half, and here we have 1 minus t raised to a minus half, and for dx we can write 2 dt. So we can now take this to outside the integral, and we have 0 to 1 t raised to half, and 1 minus t raised to minus half, and dt. So let us write this half as t raised to 3 by 2 minus 1, right? Because here we have t raised to m minus 1. So we can write t raised to half as t raised to 3 by 2 minus 1. And here we have 1 minus t raised to minus half. So this can be written as 1. Here we can write half minus 1, and here we have dt. So now this integral is similar to this one, and if we compare this integral with this one, then the value of m is 3 by 2, and the value of n is equal to half. So now this integral I is equal to 2 times the beta function, that is beta m comma n. M is 3 by 2, and n is half, right? And to calculate the value of this beta function, we can make use of one important relation between a beta function and gamma function. So now we know that beta m comma n is equal to gamma m. Then we have gamma n divided by gamma m plus n. So we can now write I is equal to 2 times. Here we have m is equal to 3 by 2, n is half. So we have gamma 3 by 2. Then we have gamma half, and here we have gamma 3 by 2 plus half, right? Now gamma 3 by 2 can be written as half times square root of pi, right? So this is the value of gamma 3 by 2, and gamma half is equal to square root of pi. And here we have gamma 3 by 2 plus half, that is 3 plus 1 4 over 2, that is 2, and gamma 2 is equal to 1 factorial, that is equal to 1. So here we have used this result, that is gamma n plus 1 is equal to n factorial. So now we can write the value of I, as 2 times. Here we have gamma 3 by 2, that is half square root of pi, and here we have square root of pi, and in the denominator we have 1, right? So we have I is equal to this 2 and this 2 get cancelled, and root pi times root pi, that is equal to pi, right? So viewers, the value of this integral is equal to pi.